Global warming.
Global warming.
Global warming. This summer already broke temperature record going back over a century. If you have turned on the news at all recently, you already know the story. The humanity running out of time. There's no walking this back. The planet is dying, and it's really hard to argue with it. Back in May,
Kew Gardens in London break Britain's all-time record for the hottest May day, then broke it again the very next day. This is the first year on record the UK has hit 35 degrees Celsius in May, in June and in July. June alone was the warmest ever month recorded in England.
So, has this ever happened before? And the answer is yes, more than once, long before anyone was here to worry about it. Earth had already lived through global warmings of its own. That doesn't make this summer any less real, it just means there's a longer story here, and it's worth knowing before you draw any conclusion about what's happening right now.
So let's actually look at the planet's temperature record.
Let's picture a time machine with a single dial, no dates, no destination. You start today, turn it back, and stop in some random point in the past. Click.
Antarctica is green, forests are growing at the bottom of the planet, on land that today lies buried under a kilometer of ice. Click. Crocodile-like reptiles are living about the Arctic Circle, in a place that's now just ice and frozen tundra. Turn the dial further, and almost the entire planet is frozen, ice reaching all the way toward the equator. Scientists call this period Snowball Earth. Then stop around 252 million years ago. Massive eruptions in what's now Siberia pumped greenhouse gases into the air and threw the climate into chaos, helping cause the biggest mass extinction Earth has ever seen. Scientists just call it the Great Dying.
So, those headlights were right about one thing. The planet has never been the fixed, unchanged backdrop that we picture when we say the word nature. It's been a furnace and a snowball and everything in between for the entire 4.5 billion years life. On a loop. But notice something hidden in the last click. Some of those swings were violent enough to nearly destroy everything, which means it's happened before was never really a comforting sentence it sounds like. If anything, it's the opposite. So, how our global warming actually look like up close? Let's start with a number that sounds too small to matter. Since 1900, the average surface temperature has gone up by 1 degree Celsius. 1 degree. That's it. You've probably felt a bigger temperature swing just walking from your kitchen into your living room. So why does everyone talk about that 1 degree like it's the end of the world?
So start with what that number is actually measuring. It's not your street or even your city, it's an average across the entire planet's surface. Every ocean, every ice sheet, every patch of land added together and divided out. And moving that average up by even 1 degree takes an almost unimaginable that amount of needed energy. Because it's not heating a room, it's heating every ocean on Earth, top to bottom, all at once.
That degree wasn't added evenly over time. More than half of that happened after 1970s. So that number doesn't describe something slow and steady. It describes something that used to crawl, but it's moving much faster, almost running. And it's not spread evenly across the planet either.
Some places has warmed 2, even 4 times faster than the global average. The Arctic is one of them, warming fast enough that people who have lived there their whole lives are watching the landscape change within a single generation. And then there's the part that breaks the pattern completely. Just south of Greenland, one patch of Atlantic Ocean has done the opposite of everywhere else. It's actually gotten colder by almost a full degree since 1900, even as the water all around it heats up. Scientists call it the cold blob or the warming hole. And for years nobody was entirely sure why one region of ocean will refuse to follow the rest of the planet. The leading explanation is a slowdown in the ocean-own conveyor belt, the deep current that carries warm water north from the tropic. When that current weakens, this is exactly the kind of patch you'd expect to go cold while everything around it heats up.
Before we talk about exactly where we stand right now, it's worth understanding what exactly changes climate that much. There isn't a single button that pushes London's temperature up to 36 degrees Celsius. Well, 22 used to be normal. The climate is controlled by something like control panel, a dozen factors all wired into each other.
3 of those factors come from space. Earth's orbit slowly stretches and rounds out over about 100,000 years. The planets still drift between 22 and 24 degrees, which changes how directly sunlight hits the poles. And the whole planet wobbles on its axis like a spinning top losing speed on a cycle of about 26,000 years. Together, the 3 are called the Milankovitch cycles. Remember that name, it comes back later. Then, there are the factors down here on the ground. A single volcanic eruption can cool the planet for a few years, throwing a reflective particle into the stratosphere that blocks sunlight. But a sustained volcanic province, thousands of years of eruptions, not just one that's close to the opposite, it pumps carbon dioxide into the air for millennia, continents drift into new positions, opening or blocking ocean currents, and those currents work like the planet's circular system. It's carrying heat from the equator toward the poles. And running through all of it is carbon dioxide. Sometimes it's just an amplifier. In orbital sheets start a warming trend. Ice melts. The ocean releases stored CO2. And that CO2 makes the warming bigger. But sometimes CO2 isn't just riding along. It's one of the hands turning the dial itself. The way it was during the volcanic province in Siberia that wiped out 90% of species.
So, which knob is turning right now? How far and by what? And speaking about knobs, there is a much smaller one in the bottom of the screen. It's called subscribe. Don't forget to click it. And we have one more interesting fact right now. We are not living after an ice age as you might think. We are living inside one. Right now.
Geologically, an ice age just means a permanent ice at the poles. Antarctica has been frozen for about 34 million years straight. By that definition, we've never left. What we call the climate is just the mild phase of that age, an interglacial, a warm between 2 much colder glacial periods. The ice sheets reached their peak about 20,000 years ago. Mild thick ice covered what's now Canada and Scandinavia. Sea level set roughly 120 meters lower than today. The glacial period itself only ended around 11,700 years ago, when our current interglacial, the Holocene, began. On a planet that's 4.5 billion years old, neither numbers counts as history. They're the last few seconds of a very long film. And that gap gave us something specific. For most of Earth's deep past, the planet was warmer than now, with no permanent ice at either pole. This current ice house phase, ice caps and all, is actually the unusual chapter, not the normal one. What's rare about the last 11,700 years is the stability of nature. Coastline stayed put, seasons stayed predictable. We didn't build civilization on some cold, default setting of the planet. We built it during one of the calmest stretches inside a phase that's normally anything but calm.
Which brings us back to where it's all started. If the planet has always swung between extremes and we're just seated in one of its unusual calm gaps between ice ages, does that mean that current warming is just Earth doing what Earth does? The argument will be alright, except one thing is quietly skips over: the difference between this is possible and this need no more explanation. People die of natural causes constantly. Heart gives out, cells wear down. That's just happened to a body over enough time. But if someone gets hit by a car, nobody says, well, people naturally die all the time. No, the fact that natural death exists doesn't cancel the need to ask what happened in this specific case. Climate works the same way. It's changed before. Yeah, it's totally true, but it's not an answer by itself. Instead of asking whether change is possible, the real question becomes what's driving the particular change right now. Does it look like the usual suspects, the orbit, the volcanoes, the slow drift of continents? Or does it look like something new? So finally, let's figure out what's different this time.
Set the current warming next to that history, and speed is the first thing that jumps out. When the last ice age ended, temperature rose about 4 to 7 degrees Celsius over 5 to 10,000 years, the fastest natural warming in the entire ice core record. CO2 today is accumulating roughly 100 times faster than it did back then. The concentration itself is just as strange. Ice core shows CO2 swinging between 180 and 300 parts per million for 800,000 years straight. never once crossing 300, and today it's about 420. To find air like that, you'd have to go back roughly 3 million years to a warmer world with forests near the Arctic Ocean. Fossil fuel carbon carries its own signature. It's missing radiocarbon, the version of the carbon atom that decays away over tens of thousands of years, burns something old enough, and that signature shows up in the atmosphere itself, diluting the isotope ratio in a way scientists can measure directly.
It's not just two rising lines on a graph, it's a fingerprint and it's still on file. Even the sky agrees, the brighter sun will hit the whole atmosphere top to bottom.
Greenhouse gases do something different. Warm the surface, cool the stratosphere above it. That's exactly the pattern we're seeing, not a brightened bulb, a thicker blanket. And the closest natural comparison we have, a burst of greenhouse gas 56 million years ago, called the PETM, still doesn't come close. We are releasing carbon 9 to 10 times faster than that even did at its peak. That leaves the dial from earlier, the orbital wobble, the axial tilt, the slow choreography of the Milankovitch cycle. Those cycles are long, but they're predictable. You can run the math forward exactly as easily as backward. Orbital cycles don't set a single global temperature. Mostly, they shift how much summer sunlight lets at different latitudes. Run that calculation for right now, with human activity removed from the picture, and one thing is clear. Orbital forcing can't produce the warming we're actually measuring. If anything, it points the other way. Its slow decline in northern hemisphere summer sunlight that's been nudging the planet toward its next glacial period for thousands of years. So, the mechanism that has paced every ice age for millions of years isn't the one driving this one. Something else is turning the dial, and we already know what its fingerprint looks like.
So the headlines had the past right. Earth has warmed before, carbon has entered the atmosphere before, life itself even reshaped the planet before us. That might be the genuinely new part of this story. One species can now extract carbon buried for hundreds of million years, release it within a few centuries, measure the isotope it leaves behind, watch the atmosphere respond and understand the mechanism while it's happening. The strange thing about modern warming isn't that Earth has never been warm before, it was much warmer.
It isn't that life has never changed the planet. Life has been doing that almost from the beginning. It's that for the first time we know of, the cause can look back at the evidence and recognize itself.
So, yes, this has happened before, just never quite like this. Thank you for watching, don't forget to subscribe and click like. See you in the next video. VOIDYWHY.